Very good morning, good afternoon, good evening, my dear students. Welcome to this DADM, which is decision analysis and data analysis and decision making 1 under the NPTEL MOOC series, and we are on the 16th lecture. This is a 30 hours lecture, which means it will be spread over 12 weeks with 60 classes, each being of half an hour. Each week, as you know, we have 5 lectures. So, we have just started 16th lecture, means we are starting the 4th week. Now, if you remember, we were discussing about, I will just repeat, go back a little bit more in the past. We discussed the 3 distributions, the T distribution. Initially, we did definitely discuss about the Z, the T distribution, the chi-square and the F distribution. And I did mention that I will be coming back to that time and again, that the Z and T would be utilized to find out something related to the mean. And chi and f would be something to related to the standard deviation of the variance. Now, we also saw in the last part of the 15th lecture that the concept of unbiasedness and consistency were important. We are not going to go into the proofs, and based on that we also gave examples that consider for an exponential distribution with a value of 0, you are picking up a sample, then the sample mean is the best estimate of the parameter of the exponential distribution. Consider for the Poisson distribution, again you are picking up observations from the sample, which consists the sample from the population, you are picking them up, and you know the sample readings, then the best estimate for the Poisson parameter is the sample mean. Similarly, for the you have the concept that for the normal distribution, the sample mean is the best estimate for the population mean. And we also saw that and I did mention that time and again, that the standard deviation or the standard error, to be right, standard error or the square of the standard error for the sample would be the best estimate for the population variance of the standard deviation. Now, remember that I mentioned about the concept of S dash and S without the dash, and in one case you had that whole factor divided by 1 minus 1, where the population mean mu was not known, hence it was replaced by the sample mean, and in another case it was divided by n because the population mean was known, hence you did not lose any degrees of freedom in order to basically find out the sample mean, because the population mean was known. Now, I will proceed further with the concept of in this statistical inference problem, go through the basics for point estimation, interval estimation and hypothesis testing, and then further on considered for the multivariate analysis and so on and so forth. Now, in statistical inferences you have 3 areas, which is basically point estimation, where you find out a point, a value like the sample mean as the best estimate of the population mean, or say for example, S dash or S without the dash is the best estimate for the standard deviation for the population giving some conditions. So, whatever it is, we want to find out a particular value and check that the concept of unbiasedness and consistency are met by that point estimate. So, there are different ways how you do that. 2 of the methods are quite popularly used are the method of maximum likelihood and the method of moments. I will very briefly discuss them without going to the proof. I will basically come to the results. Now, in the method of maximum likelihood estimation, MLE method, what we do is that we want to find out the values of the parameters which are unknown, based on the fact that the sample which we pick up with the set of observation x 1 to x n are such that they give us the maximum chance of finding out the highest probability, such that the corresponding parameter values basically substantiates that. I will come to that concept in a little more detail through qualitative as we talk, without in going to the quantitative concepts. So, in the MLE method, the likelihood function, so we would basically define a likelihood function is defined by the concept that signifies the chance or the likeliness or likelihoodness of the function taking a value based on the realized value. So, consider the realized values are basically x 1 to x n. So, considering that they are x 1 to x n, obviously, the corresponding to the first reading, which is x 1, you will have a corresponding probability for the for the from corresponding from the PMF or the PADF, whatever you are going to consider, for which the parameter value theta is unknown. Similarly, when x in the second set, when you pick up the observation and it is x2, small x2 realized value, then the corresponding PMF value would basically be given by the value where you put on this x as equal to x2, but considering the parameter theta is unknown, and then we find out that probability given parameter value is unknown. Similarly, we do it for x3, x4, x5 and so on and so forth. So, what we want to do is that we want to basically, and there are IIDs, remember that. So, if there are IIDs, what we want to find out, if we want to find out the probabilities being multiplied such that they give us the maximum value, and based on the fact they give the maximum value, we would basically like to differentiate that functional form which is an unknown in theta with respect to theta, put it to 0 and find out the best estimate of theta for which that case would be true. The main focus of this method is to find the estimator such that the likelihood function is maximized. So, log likelihood, it is generally mentioned because we convert the likelihood function into the log likelihood function with the logarithmic, and hence it is easier for us to differentiate, because logarithmic is a increasing function, then hence trying to find out at what value of theta that log likelihood value takes the maximum one is easy for us to find out, and we can basically comment intelligently what is the value of theta, which is basically theta at, and that characteristics is from the sample which basically gives us the best estimate of the population parameter theta. So, consider we take a set of observation x1 to xn, and we have the distribution function, consider the PDF or the PMF whatever it is, that is given by f of x comma theta. So, that means if it is, say for example, so say for example, you have the, I am using the red color. So, consider you have the exponential 1. So, in this case theta lambda, this is unknown. So, say for example, when x takes the x value x1, x of x1, then you put that x as x suffix 1 and find out what is the corresponding PDF or the PMF based on the fact that lambda is an unknown. So, that would basically be your case where we get f is equal to x1. Technically, this means probability so similarly we find out for x2, I am just writing it out. Then we find out for the next reading, third reading, x3, then x4, x5, x6 continue and multiply all these values in order to get the so called maximum value. So, this is what we are trying to do. So, consider x1 to xn have the same distribution function, they are IID, that means identical and independently distributed. The same distribution function f of x given theta, which is the parameter, theta is unknown, remember that, and x1 to xn are the corresponding realized values for capital X1, for capital X2, for a capital X3 till capital Xn respectively. As all the xi's are IID, hence the likelihood function corresponding to the fact that x takes x1 in the first case, x takes x2 in the second case, x takes x3 in the third case, so on and so forth till the last case when x takes xn in the last case, is given by the corresponding probability being multiplied. So, when I mentioned this, actually this value is basically what I have written. So, that means I have written suffix x1 for the case of capital X, that corresponding to the fact that is the random variable which will be akin or the characteristics will be given for the first reading. Similarly, capital X2, capital X3, so on and so forth. So, we multiply these values, these are multiplication signs where I am hovering my pen. Now, considering that we want to find out some theta. So, if we want to basically maximize the probability, so which means that that value of theta which gives us the maximum chance on picking of this observation should be the parameter value such that we are able to maximize the probability. So, once we basically multiply the probability corresponding probabilities for the IIDs, we find out the log likelihood function, because as I said this is a monotonic increasing function. Once you find out the log likelihood function, x1 to xn are all known. Now, the value which is unknown is basically a value of theta. So, if theta can be, in case of a normal distribution, there can be two parameters mu and sigma. For the case of exponential, it can be a and lambda, depending if a is non-zero. In case a is 0, then it will be lambda. We maximize the log likelihood function by differentiating. So, I will remove this, because or else it will be . So, we maximize the log likelihood function by considering and differentiating this. So, these are the so the del of ln of log of L of x theta is the log likelihood. So, likelihood function we convert into log likelihood and differentiate with respect to theta, put it to 0 and finding the estimates of theta. So, once we put it to 0, you will have different values of theta. So, those would be the estimates of theta, and we technically write that as theta hat. So, once we differentiate, put it to 0, that value of theta which we found out would be basically the corresponding characteristics would be coming from the sample only, because here inherently the x1 and xn are known to us. So, once we find out x1 to xn, we put it back, again I am repeating, find out the likelihood function, then find out the log likelihood function, differentiate with value of theta, partial differentiate, put it to 0, find out this theta hat. In the method of moments, we work in a slightly different way. So, moments, if you know, the mean value is the first moment, the variance is basically is actually the second moment concept which is being utilized to find out the variance. So, variance basically uses the second moment and the third moment. Similarly, we have the for the variance we use the second moment and the first moment, my apologies. For the third moment we use the concept that given the third moment you can utilize the first, the second and the third to find out the skewness. Then once we find out the fourth moment, we can utilize the first, the second, the third and the fourth to find out the kurtosis and so on and so forth. So, what we do is that depending on the parameter values, how many of them are to be found, we derive the equations that relate the population moments to the parameters of the interest. So, say for example, parameters for the case of exponential distribution or for the case for normal distribution. So, the parameters would have some relationship with the moments. So, the first moment would basically the first parameter for the normal distribution. Second moment would basically given by the mu and sigma square, such that we can find out the relationship between the second moment and the first moment and the variance. So, if we have the relationship between the moments and the parameters, we basically write down those equations. So, if consider that you have basically k number of parameters, you will basically have the first moment, second moment, third moment, fourth moment till the kth moment, and they would be given by the equations g1 theta 1 to theta k, because all the parameters would be taken into consideration. Some may be 0 due to the calculations, but we will take basically all of them into calculations. Similarly, we will find out the second moment which is mu 2, which will be given by g2, a function of theta 1 to theta k, till the kth moment would be given by mu k is equal to g k and then functions of theta 1 to theta k. So, once we have basically have the formulas as per the theoretical norm, what we do is that first we basically find out the first moment with respect to the sample characteristics which we have found out, and basically utilize that sample characteristics in order to basically estimate and find out the moments one at a time. So, say for example, we have the sample mean is utilized to find out the first moment. So, we get some information of the mu. Similarly, we have the sample, from it we find out the sample variance, utilize the sample variance and the sample mean to find out what is the population second moment, or also find out what is the variance of the population. We go step by step, find out if they are closed form solution, well and good. If they are no closed form solution, you do some iteration method to find out that how the sample information, set of information from the moment point of view, like the first, second, third, fourth from the sample can be utilized to find out the first, second, third, fourth moment for the population. Hence, we can find out the parameters for the population as such. So, it is written there in the second point. After that, a sample x1 to xn is drawn and the population movements are estimated for that. So, here we consider mu I and there is a suffix e means the estimate. So, the estimate of the sample, the moments would basically be found out from the observations x1 to xn. These are the characteristics corresponding to the set of observations x1 to xn. They can be equated to basically the functional form which we have initially derived, but from there what we will find out is basically not the parameter's estimate which will be found out, and then we will try to compare the estimate of the parameter with the parameter itself, and then basically go into the characteristics of the unbiasedness and consistency and comment intelligently accordingly. So, from the sample we find out, let me read it, mu I e, and I means the ith moment, e is basically the estimate, is a function of x1 to xn. So, that will be given by, so for the first case it will be given by g1 and it will be a function of the estimate of theta 1 to theta k. Second case it again would be basically g2, a function of theta 2 to theta 1 to theta k, but here also remember they are the estimates. We continue doing that such that we are able to find out this theta 1 estimate, theta 2 estimate, theta 3 estimate, so on and so forth, which are the best estimates for the actual parameters which are theta 1, theta 2, theta 3 till theta k. So, if you have basically the mean value only, you will use the first moment. If you have basically the variance, you will use the first and the second moment, and so on and so forth. This is a slide which is a repetition, but I will still repeat it because this would be coming time up again generally when you are trying to solve the problems, but obviously the answers generally the proofs would not be given or they are not required, the final answers would be given for those proofs, and those answers would be utilized to basically find out the point estimate and utilize the point estimate to find out basically the interval estimate and do the hypothesis testing. So, any statistic, a random function which is used to estimate the population parameter basically should have basically two characteristics, one is the unbiasedness and one is the consistency. In unbiasedness, if you remember that what we want to do is that I will draw the same diagram which I have done. So, let me change the color such that it is easy for us to follow. So, this is the x axis, this is the y axis, and consider we have chosen observations for two different populations and consider them both of them are normal. So, let the set of observations for the first one be red in color, and we have picked up say for example 6 observations. I am drawing them arbitrarily and the mean value is like this. So, the mean value is the central line, the variance is basically this and the distribution looks like this. So, this is normal. Next, consider we pick up a second set of observation again 6 in number from a normal distribution, but now the color combination is green. So, here also the mean value is same. So, the expected value, let me use the highlighter, the expected value in both the cases for both for the red as well as for the green are same, which is this is the central line. But if you go to the second characteristic which is consistency, you will find out the difference between the actual estimate value and the parameter value from the population, they are basically a function of n, because as n increases obviously T n would actually approach the value of theta which is the population parameter, and the distance between whether it is on the positive side or the negative side will start decreasing such that the epsilon value which you have put for ourselves in this case is a function of n, and in the long run as n tends to infinity the difference basically goes to 0 with a probability 1. So, which means that as sample size increases the distribution, let me use the black color. So, these are I am utilizing as for any of them whether for the green or the red, as the sample size increases in the long run the distribution looks like this. So, it basically peaks and basically gets concentrated in around the mean and hence the variance decreases. Now, consider the concept of interval estimation. So, this point estimation would be followed up by interval estimation, and there would be logical flow from there. I will come to that later as we solve the problem. I will point it out to all my students. Consider x1 to xn have the same distribution function, which is basically, so I am considering they are I have a population, from there I am picking observations and they would be IIDs. So, obviously, because one observation does not affect the other. So, we will consider IID and they are coming from the same distribution. Consider x1 to xn have the same distribution function f of x given theta as the parameter, that theta can be vector or scalar, that does not matter, and we consider x1 to xn are IIDs and the corresponding realized values of them are given. So, what we are interested in is, given that x1 and xn and depending on the level of confidence of the probability value of how good or bad our set of observations are, we want to basically find out two estimates or give us two functional form. So, those two estimates would basically be a function of the sample estimate such that within that bound of the lower and the upper estimate, or the lower control value and the upper control value, we will find our actual population parameter, which is the mean or the standard deviation or the mode or the median, whatever it is, with a certain probability, where that probability has already been being dictated by us before we solve the problem, or it has been given by the external sources. So, those basically functional forms based on the sample set of observations would be given as T1 or T2. So, those functional forms I will come to that in few minutes. So, T1 and T2 would basically be the functional forms based on which we will find out the lower control limit and the upper control limit, and these T1 and T2 are just functions based on the fact that you have picked up observations x1 to xn. So, what we want to find out is this, I will draw it here and use the red color for ease of understanding. Okay, first let me draw the line and straight line, and then try to basically give the color combination concept. So, consider this is the line. Let me check. This is the x axis, and consider this is the mean value. Now, what T1 and T2 mean are actually this. So, T1 is a value on the left hand side, which is a function of x1 and x2. T2 is a value on the right hand side, which is again a function of x1 to xn, such that the overall area in which, so consider any distribution, I am not drawing the normal case, any distribution which you have, such that the bound which I have would contain the mean value or the parameter value from the population with the probability of 1 minus alpha. So, this is the 1 minus alpha, the level of confidence we are seeing. Now, if it is a symmetric distribution, what we will do is that I will use a different color. No, this yellow will not go, let me change to blue. So, this left hand side probability and this right hand side probability, they would be such that the sum of, consider I am using the black color also again, this is alpha 1, this is alpha 2. So, alpha 1 plus alpha 2 plus 1 minus alpha, which is the level of confidence in between, should add up to 1, which technically would be the case as discussed. But the beauty is that we considered a symmetric distribution and we considered alpha 1 and alpha 2 be equal and equal to half alpha by half. So, that means the central portion will be 1 minus alpha, the left and the right portions onto the left of the LCL onto the right of the LCL would be equally divided. So, technically alpha 1 value, alpha 2 value would be equal to alpha 2 so as the addition of this plus this gives me 1. So, we are interested to find out lower control limit and the upper control limit, which is given by functional forms T1 and T2, such that the probability of the mean value or the parameter value of the population being bounded by that lower control and upper control is given by 1 minus alpha, which is the level of confidence. Without the derivations, I am just and I am just giving the results. So, statistical inference for the interval estimation for the mean with the standard deviation on the population variance for the standard deviation for the population or the variance of the population is known, because that is why it is highlighted in red color. So, if that is the case, what you will do is that if you know the best estimate. So, I am basically now going through the background of the story without going to the details. So, obviously, if the mean value is unknown, so obviously you have to estimate from the sample. So, your first question would be, if I want to basically estimate from the sample for the normal distribution, what is the best mean value? So, we know that is the sample mean. Now, we will also ask that if the population variance or the population standard deviation is known, then how should we solve it? So, we will think and remember that the sample mean, as it is the best estimate, hence its distribution is normal, which is true. The mean value for that sample mean is mu, which is also true, and the standard deviation or the variance of the sample mean is given, if you remember, by sigma square by n. Now, if it is given by sigma square by n, so now we have x bar n, which is basically the sample mean as normal distributed with mean mu and variance sigma square by n. Hence, if it is normal, it can be converted to a z normal z value, which is the standard normal distribution, and it can be converted into a standard normal distribution. We can find out T1 and T2, which is the lower control and the upper control, based on which you can find out that given a probability that what are these T1 and T2, such that they would encompass the sample and the population mean within itself with a certain level of confidence, which has to be specified beforehand. So, now if I have normal distribution, I am drawing it in order to make you understand. This will be applicable for all the cases. This is for the actual sample mean. Mu value, the mean value is mu, which is here. The standard deviation is given by sigma square by n. So, this is the standard deviation. Now, I convert it to a standard normal. So, let me remove it. So, this becomes 0 and these are the variance 1, 1. This value is z1 corresponding to x1. So, I have to find out x1 means those are not the observations, x1 to xn, those are not, those are basically the, let me put it as z LCL and z UCL. So, they are basically coming from T2, which is coming from T1 using the standard normal deviate. So, once basically I find out that T1 and T2 corresponding to the z distribution, and when we use the x bar distributions are. So, this is the LCL, if you remember alpha by 2, because if you remember I said that alpha 1 and alpha 2 are equally divided. On the right side the UCL is this plus value. So, this is minus and this is plus. So, they are used accordingly, such that your equidistance from the mean value, that will be equal to 1 minus alpha. Based on this, you can find out the interval estimate and conclude your problem accordingly. So, I will keep repeating these type of problems for the mean values given standard deviation known, not known, for the standard deviation given mean values known, not known, and try to basically utilize the concept of the z distribution, the t distribution, the chi-square distribution and the f distribution, and then utilize them further on when we come to the multivariate statistics. With this, I will end the 16th lecture, and thank you very much for your attention. Have a nice day. Bye.